This is the screencast for section 1.2, example 6, increasing and decreasing and actually constant functions. We're not worried about where a function increases or decreases to. We just want to know whether the function is moving up in general or moving down. That's what increasing and decreasing is asking us to do. And then therefore, where on the x-axis is it doing those things? So for example, this function right here is increasing. It is moving up from left to right. As a matter of fact, all over the x-axis. So the x values where the function is moving up are from negative infinity to positive infinity. I understand it's only moving up from maybe -1 to +1 or -2 to +2, but that's range. That's not what we're talking about. We're talking about where on the x-axis does the function move up. Decreasing is asking where on the x-axis does the function move down. So this function, even though it goes from positive infinity down to maybe -2, I'm actually looking at where on the x-axis. So from -2 to positive infinity, the function is in general moving down. The constant function stays the same. Yes, it stays the same at +2, but that's the range. I want to know where on the x-axis is the function staying the same, so from negative infinity to positive infinity. Now an example that includes all of them would be this one. From negative infinity to -2, the function is decreasing. There it is, negative infinity to -2. Then from -2 to +2, the function is constant, staying the same. Then from +2 all the way out to positive infinity, the function is moving up, increasing. So example 6 asks us to identify the intervals where the function is increasing and decreasing for parts A and B. On part A, this function x plus 2 squared, I know it's going to be a parabola. I can see what it looks like here. This bottom point right there is going to be -2, 0. I could graph this in my calculator and make sure that point is -2, 0, but I also know that -2 plus 2 is 0, squared is 0. There's my minimum. Let's see. So the function is decreasing all the way from the left up until the x value -2. So we are decreasing from negative infinity to -2. Now I put parentheses at the end. Your book will probably put a bracket at the end of that. It's hard to say whether -2 is included in the decreasing part or the increasing part, because can you be increasing and decreasing at -2? No. So I just leave it out and use the parentheses. Now to continue on, from -2 all the way out to positive infinity, the function is moving up. So it is increasing from -2 to infinity. Part B. A little bit more difficult. Let's see. I can see that the function is very gradually moving up, all the way from negative infinity to what looks like -1. Now I can see in the denominator -1 squared minus 1 is going to make the denominator 0, not the numerator, so I know I have an infinite discontinuity here at -1. So far my function is increasing from negative infinity to -1. Now nothing happens at -1, so in this case I absolutely have to leave -1 out of my increasing interval. The function is not increasing. So if I put a bracket there, that would be wrong. Nothing is happening at -1 on the x-axis. I have to leave parentheses. Now after -1, I start back down at negative infinity, but the function is still moving up. So I'm going to add on to my increasing intervals from -1 to, I think that's 0. So 0 squared over 0 squared minus 1 is 0. So I can see that I hit this point where my function stops increasing and then starts to decrease, which leaves me to my decreasing intervals. The function is decreasing from 0 to +1. +1 also makes the denominator 0, so there's an infinite discontinuity here. Therefore, nothing is happening on the graph at +1. So this piece of the graph that is going down happens between 0 and 1 on the x-axis. Then after the value positive 1, the function is still moving down all the way from 1 out to infinity on the x-axis. Now the now try problem, I'm going to have to graph that. I'm not really sure what that looks like without putting it in my calculator. So we're going to go 3 minus x minus 1 squared. Graph. Alright, that looks like it makes sense to me. That's a parabola. You know what though? I'm going to delete that. I want to know what this value is up here. That value looks like a maximum to me, so I'm going to go second calc maximum. It asks me for a left bound, so I have to go to the left of the maximum, hit enter. Now it's asking me for a right bound. I'm going to go to the right of the maximum. You don't have to go too far, just a little bit. And then it asks me for a guess, so I'm going to go right where I think the maximum is. Now I know my calculator gives me that 0.999999, but it is 1 comma 3, and I know that because 1 minus 1 is 0 squared, and then 3 minus 0 is 3. So the maximum happens there at 1 comma 3. So now I can tell the function is moving up until we hit the x value positive 1, and then after the x value 1, the function is moving down or decreasing. So we're going to increase from negative infinity on the x-axis to positive 1. Then the function is going to decrease for the rest of the x-axis from positive 1 all the way out to the right to positive infinity.